Okay, with substitution, what's the first thing I'm going to do? Yeah, okay, so what's u going to equal? X squared plus 4. Okay, so I then rewrite my equation. 3x times u to the power of 5 with respect to x. Can I integrate that like that? No, what do I need to do? Yeah, I need to integrate with respect to the right letter, eh? So if u is that, then du by dx is simply 2x, isn't it? So therefore, a half of du is the same as x dx. So substituting x dx, which is that part and that part, now becomes a half of du. So now I'm integrating 3 lots of u to the power of 5 times a half du. Does that make sense?
So the extra x gets rid of that x.
Yeah. This x dx here gets rid of that x there. Okay, and that's the reverse chain rule. You can actually note, if you can notice that, then it becomes a little bit easier. Yeah. But I think actually substitution method, if you do the substitution method, it comes out in the wash anyway. So now this is integrating 3 over 2 u to the power of 5 with respect to u, which is the same as integrating u to the power of 5 with respect to u with that 3 halves out the very front. I'm going to integrate that. Hopefully you guys can click on that's just u to the power of 6 over 6 plus c, which is 3u x squared plus 4 to the power of 6 all over 12 plus c. Yeah? Does that make sense? Can you see where everything is? You see how it sort of makes it easier and then put it back in and it looks real complicated at the end? So if we're looking at exercise 2 then, or example 2, can you see that this part here is actually some part of a derivative of that? Okay, that, if you can notice that, then the chain rule or the substitution method comes pretty handy. So let u equal x squared plus 1. I'm going to find du by dx at some stage anyway, so I'll just find it now. So therefore du equals 2x dx. Okay, why have I left it as 2x dx? Yeah, because 2x dx goes into 4x dx. Yeah, exactly. So now this 2x dx here combines to make that. It's going to be 2 lots of e to the power of u du. Can you see that?
Yeah.
Okay, I've missed out a step or 2 there. So now when I integrate 2 eu with respect to u, what do I get? Is that A? When you integrate EU, you get EU. Isn't that on your formula sheet? Yeah? So then I get 2 EU. U is x squared plus 1 plus c. Okay? I can always check my answer. I can go 2 lots of e 2x plus 1 times the 2x. Oh yeah, there's my answer. Happy with that? Now, example 3 there. I'll go to example 3. I'll leave that page up. I'm not going to stand up here and say that looks pretty easy. Shock horror, apparently. So let's go let u equal sine 4x minus 2x. Du by dx is now 8x minus 2. Is that right? So du is 8x minus 2 lots of dx. Is that right? But that's not what I've got on the left hand side, eh? So what am I going to do then? This is half of it. I need half of that, eh? To be my 4x minus 1. So what do I do? Half du is therefore half of that dx. Happy?
And you also halving the dx.
Well, I am halving the dx. This is that times dx divided by 2. I'm halving it all rather than just halving the dx. Why would I not double the du? I don't know, what do you reckon? Haven't I got... don't I want 4x minus 1? So how do I make this 4x minus 1? I halved it, so I've got to do half this side, I've got to half the other side as well. So this now becomes sine u times du, with that, take the half at the very front, half sine u with respect to u, integrate sine, you get negative cos. Those ones confuse me. Integrate sine, you get cos, negative cos. So therefore you get negative cos 4x squared minus 2x all over 2. Plus the c, yeah. Plus the c for anyone who's about to do it. I think I said it first. Does that, are you sort of following where you're going there? Is that hard? The reverse chain rule, I feel, we haven't even done the reverse chain rule here. I've done is just done the substitution method, but with much harder questions. So I don't know, I reckon try the substitution first, and eventually once you get used to the substitution method, the reverse chain rule, you can actually notice it. And once you notice it, then you potentially don't have to use the substitution method. Any questions? All right.